Welcome, everyone. Thank you so much for joining us. My name is Monica. I work here as a product manager at Starburst, and I am so excited to have Rajesh and Karthik with me today from Asurion. They are both fantastic. I've had a lot of joy speaking with them in all of the prep calls, and they're really, really smart people too. So I'm so excited to have them dive into a little bit about what's going on at Asurion within the ML AI space. They're going to tell us a lot of interesting things that I think are going to be beneficial for you on your own journey. As Rajesh and Karthik and I were talking about this, they made a really good point that's kind of stuck with me since that the whole goal of sharing these stories is to share the knowledge among other engineering peers. So they are going to do a Q&A at the end. So please, if you have any questions while we're going through any of the material, go ahead and post them in the chat and we'll be able to pull those up at the end and get your questions answered because this is going to be a lot of awesome knowledge in a very short amount of time. So go ahead and ask those questions that you think of and we'll be able to get them answered. Now, I have a couple of housekeeping items before we completely jump in. I want to just share that we have a lot of really awesome and excellent events coming up here at Starburst. We have demos, we have workshops, we have case studies. So if Anna will pop that in the chat, if you are looking for other material or other live events, this is the place to go. We have a lot scheduled and of course, as always, reach out to events at starburst.io if you have questions, Anna and I can answer them. And we're going to wait just 1 or 2 more minutes and then we will jump. We have a lot of material to get through today, but I just want anyone transitioning from their last meeting who wants to join live to be able to. So we're going to just give it 1 more second and then we will jump in. Again, if you have any questions throughout any part of this presentation, please throw them in the chat. We are going to have Rajesh and Karthik answer questions that you have at the end of the presentation. And so with that, I think it is time for us to get going. To start off, as we do, Rajesh, you are the Director of ML Engineering and Gen AI at Asurion. Can you tell us a little bit about your background? Go from there.
Sure. Hey, everybody. First of all, thanks, Monica and Anna, for having us. And we're really excited to share all the work that we have been doing for the past few months. My role at Asurion is primarily responsible for enterprise data services, architecture, solution platform, and data architecture, data quality. And on the Gen AI side, ML engineering is one of my responsibilities.
Awesome. Thank you so much for being here again. And Karthik, can you share a little bit about your role?
Yeah, thanks, Monica. Hi, everyone. Good morning. I'm Karthik. I've been with Assurant since 2019. I'm mostly focused on building data products, data solutions, frameworks, and recently I've started building Gen AI applications using RAG and chatbots. So I'm excited to share our journey with NLP.
Awesome. So you two are the brains along with your team and all the other people behind the scenes on what we're going to see today, which is really awesome. Before we jump in there, I was wondering, Rajesh, if you could tell us a little bit about Asurion, what it does, just some intro before we jump in.
Definitely. So Asurion is, as you all know or may not know, is a tech care company, and primarily we work with almost like 300 million customers all over the world for protection plans, insurance plans, repairs and replacements, and basically we work with or we try to protect and help customers with anything that has a power button. That is how we say. And it's in other words, like we care for people and their tech whenever, wherever, and however. And then we are a global brand, and we are across the globe, and we have 700 retail stores, and our ratings are like 4.5 and above in all Google and other rating sites. And we have over 9,000 plus experts who are available to help our customers virtual, in store, and on the road. And we also cover through that network, we cover over 88% of US population. So in a nutshell, that's what Asurion does.
That's awesome. So where can they learn, where can any attendees learn more about Asurion? Just type in Asurion and we'll pull up the website?
Exactly. You can go to
Perfect.
Asurion.com and you can learn a lot. And if you will also would have seen some of this in if you either you're trying to purchase some electronics or things on Amazon, or if you walk into a Verizon or AT&T store, and if you're purchasing a phone, I mean even online, you would get the pop-up that shows Asurion trying to help the customer saying, "Hey, do you want to add this protection plan?" So you can learn more about there as well.
Yes, I've seen the pop-up. I have seen it. I haven't quite used it yet, but now that I know all about the background, maybe that's something that I'll do next time. So Rajesh, you and I actually met last year, which was really, really cool. We got to meet at Data Universe when we talked a little bit about some of the development work that y'all have done around machine learning and data quality. Can you give us a little bit of an update? So let's dive into a little bit of an update on kind of where you stand there. But to start with that, let's discuss like what were the challenges y'all were facing before that presentation?
Yeah. So we were facing the same challenges every other data engineering and data platform team would, which is at scale we are processing probably thousands of jobs every day, which are reading data and writing data into thousands of tables, processing pretty much like billions of records, and all of that scale comes at a cost, which is like you need to be able to balance providing data to our business partners, the right data at the right time. So the fundamental thing that came out of all of that is like our business users or any business users would really care for quality of the data to make the right decisions. And it doesn't matter how fast you provide the data. If the underlying data is flawed, then the decisions are going to be wrong and the data is invaluable, or I mean it is useless pretty much, right? So those are the kinds of issues or problems that we were facing when we were when we were at the same time last year this time.
I know it's crazy to see how much progress has been even in just a short amount of time. I remember that presentation completely blowing my mind as what y'all were talking about. Can we dive into a little bit of some of the gaps you were seeing in data quality? Like what wasn't being fulfilled in a way?
Right. So one of the first things that we wanted to do is, of course, like we wanted to understand like what all issues are there. Like how do you even, so it's like if you want to be able to control something, you would need to understand, first of all, the depth and breadth and all the dimensions of this. So we wanted to understand where all these issues are happening, how often are they happening, why are they happening, and how do we categorize them into buckets so that we can actually say, okay, these for these kinds of issues probably this is the best solution, and for these kinds of issues this is the solution. So we were even before getting into the actual solution, getting a grip on what's the breadth and width of the impact of data quality, and at how many stages is this happening, and all of those things where we spent significant amount of time in learning how do you categorize this so that we can actually methodically approach each one of them. So that's what we did in terms of categorizing all of that. The metadata gaps were pretty much when you do that, and if you want a framework to be able to handle all of these issues, right? You want a lot of metadata to be defined well upfront. So that is one of the fundamental or foundational elements that we stress upon is metadata is foundational. So we also fortunately we have a good metadata culture at Assurance. So we have enough metadata, but we stressed on that, and then we took advantage of that to drive and add the data quality framework on top of it.
That's awesome. I think you're kind of just saying what everyone is experiencing right now of how doing that next stage in the AI journey, it's really critical to have that data piece in the right way. I'm going back to what you said of like the data is useless if you don't have that, right? That is so important. And I've had the same experience in my previous jobs. And then I want to talk a little bit about like the downstream impact. You kind of mentioned it, but how is this affecting teams downstream from you? Because obviously I'm sure you have a ton of business users, or what kind of downstream impacts were you seeing?
Right. So there are two fundamental impacts here. One is to the engineering team itself, meaning our engineers and our analysts and our data product owners. So the impact to them is, instead of deriving value out of this data and providing business with the right data, so they spend most of their time in chasing down these data quality issues and trying to uncover where all this bad data has actually seeped into, and then trying to recover that. So basically, it is not a fun experience in trying to one step forward and then two steps back, right? So you launch something, but you are now stuck in just figuring out the issues rather than deriving value out of that. So that is one side of this impact. The second is our business. So of course, the obvious outcome is they are not able to use the data, right? But what happens after that, a couple of these is, the most important thing is trust. So your business users would lose trust in the data, and then what happens is they would not be consuming the data, and they would probably find other ways to consume data. Maybe they'll try to download this data into Excel sheets and then start working their way, because they're no longer confident of this data, right? So that is actually more worse than the first one. So those are the two major impacts that we have seen.
I that is exactly the experience I'm sure a lot of people are feeling who, have gone through the same way. I can just, thinking about it as bringing back memories for me. Now, so the great news is that we have seen progress here from the Asurion side, where we all know about the problem, but you've been able to implement a solution. So, can you talk a little bit about what you've done to sort of proactively identify these issues and change that pattern?
Yeah. So, again, going back to what I said earlier, is first of all, we tried to categorize all of these, right? So, we did a good job at categorizing our types of data quality issues into 6 buckets. And one of those, or the easy ones, are the ones where you can write SQL queries and you can basically validate the business using basically business rules and SQL validations, right? Then the medium ones or moderately complex ones are the ones where you 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 cannot write a SQL query to actually validate that. For example, the daily the files are supposed to arrive, but they don't arrive today. Or you're supposed to get like one file, but you got like 15 files. Or you're supposed to get 20 files and you got only one file. Or you got like a file which is supposed to have 10 columns, but you have like 9 or more. Or you got exactly the same number of columns, but they shifted a little bit to the left, and then there is a null at the beginning. So there are so many these types of issues where you need a little bit more than SQL, right? You need something like that is where we spent enough time and invested time in coming up with a machine learning, uh, using machine learning for these kinds of problems. And then there is an advanced version of that, which is the even though the data is all in place, and you have the exact number of records that you're supposed to have, then you have a fundamental, what do you call, relationship, inherent relationship between the columns and the values in those columns, and that is what we call structural integrity. So that is actually way advanced, and that is probably the last 10% of figuring out your data quality issues. So that is where we spent significant amount of time in the last couple of years. So
Got it.
that's how we try to solve the issue.
Right. So what has this looked like now? So what has the launch to production looked like? Where are you at now? What have you seen since then?
Right. So at the same time last year when we were presenting it, we were very confident about our initial results, and we launched it in a small scale. And after that, like we we launched it at a full pace throughout the second half of last year. So the results were like amazing, and it was one of the highlights for last year for our entire data platform, because I'll show in the slides. Actually, the graph speaks more than me saying this, but the average over the past since we were tracking this, the average of the incident rate dropped by half. So we are now 50% lower in terms of the number of incidents that are being created because of bad quality of data. So that's as simple as the impact or the outcome.
That is crazy. 50% less pings from your own team, your business users. That is so nice. You can start actually working instead of just like, the cycle to deploy a data pipeline is a lot already in itself, but now having to not, and you can take maybe those 2 weeks of post prod validation down to one. That is insane. That's really cool.
Yeah.
Really cool stuff. Okay, did you see any business improvements? Because obviously we talked about the
Oh,
technical improvements just there. Were there any sort of like business improvements? Did that trust start to build back?
Exactly. So that is what, like, now, because of the 50% drop in the incident rate, and this is an average. So in some months we are seeing over 70% drop from the average. So what does that gives both of our operations partners and our engineers more time back to do valuable things than again chase down the bad quality data. Two is we are preventing bad data from, so even in those 30% or 40% cases, we're preventing data from being seeping into the downstream system. So it is easier to clean it up way upstream than clean it up downstream. And the big outcome is trust. So we have seen a lot of improved trust in the data and usage as well from our business users because of these. So that also puts the platform in a much more stable place than earlier, where we were constantly battling data quality issues and availability issues and whatnot. Yeah.
Yeah, that's just so tremendous and really exciting. As you build now, is there anything you're looking forward to improve some of those models that you have? What are your future plans there?
Yeah, definitely. So one of the things that we are trying to do is, even so, of course, we have to clean up our house first before we go and start to say, okay, how do I influence everybody else, right? So we I think have good control on what we can do here. Of course, there is always room to improve, so we want to take that 50% to down to probably 10% or even less. Those are the aggressive goals that we're setting. And there is always going to be continuous improvement in trying to find those edge cases and all. The big thing that we are trying to do is, now, if I draw the lines of the scope of this team, which is the enterprise data services team, our scope starts from the point where the data enters our system and all the way to deliver to our business users. So no matter how much we do here within these boundaries, we can only do so much. So there are things that you can influence upstream. So we are trying to see how we can actually help those teams use these frameworks so that we can actually push this a little bit upstream, right? It's kind of like shift left approach, where you're trying to go and say, okay, even before you produce the data, can you use these frameworks and try to fix the data upstream, so that not only just us, but anybody else who you are sharing the data with will be benefited. So that is actually something that we are trying to influence.
Oh, I love that. That's so cool. And then you'll see, it'll be really interesting to see next year the even more exponential results that you can come report back.
Yeah.
Okay, with that, let's shift a little bit into this new use case that the two of you have. Karthik, Rajesh, I'd love for y'all to talk a little bit about sort of this natural language processing work. So let's go ahead and get those slides up there so we can share a little bit about this new use case.
Yeah. So again, I added the links to the previous webinar conference link, and these are the quality issues that I talked about, and these are the results. You can see everything past that launch is like kind of half of where we were earlier. So coming back to the actual topic, which is data democratization and NLP based analytics. So we have been working on this for a few months, and we have done, I think, a tremendous amount of progress, and of course, a lot of lessons learned, which is what we are really excited to share. So we have fundamentally learned what it takes to enable NLP-based analytics on top of an existing data platform, and then what does it actually beyond what we call is this is like beyond the hello world, because the hello world kind of demos are really easy, where you have a single, probably a few 10 to 15 tables, and then the schemas, and then how they're related, and enabling some chatbot on top of it which can write queries is the easy part. But we are talking about handling this at the scale of like thousands of tables, and also probably thousands of KPIs, and at the scale of Asurion at least. So it is quite different when you go from a single instance to something like thousands of tables and trying to run this at scale. So I'm really excited to share all the details, and I'm going to hand it over to Karthik to walk us through our lessons learned and how we did it, and then we can wrap it up with it. Karthik.
Thanks, Rajesh. Thanks for that background. Let me start by providing some context, like how we are going about this, like democratizing the data. So in initial days, let's say like evolution of how the data access and the technical gap between the business users and the data engineers or the analyst and data product teams, how it's been evolved. So initial days, like if you see, we have strictly the reports were created by the IT departments, and they have to wait for weeks, months, days in a way. And then there's a lot of bottleneck, because to make the decisions they used to wait for a long time. Then the next phase was in 2000s. We have this like democratization of visualizations, where you have Power BI dashboards, like Tableau came into play, SSRS, a lot of reporting came into play. But still there is uh, the technical gap is still there, because there's a limitation on how we can rebuild those data marts on top of it, and business users doesn't have any visibility on that side, and they have to rely on the technical users. And then there's a SQL bottleneck phase, where still we have all the visualizations, but there are some gaps where you have to change the data marts, how we can break things up. That's pretty back and forth. There's a lot of waste of time for the data engineers, analysts, to get the solution what they wanted. So this is where I'm heading towards. Like, so it's an interface where we are trying to introduce. It's an NLP based, where technical business users can talk in a plain English language. Like, there's no technical knowledge needed. They have a domain expertise, but what they can do is the system can understand that business terminologies and break things up, and comes back with an insights and visualizations on top of it. So here we are trying to show how the system looks like, the UI, what we have built out. So on the left side panel, we have model listed and session history based on the user. And then if you see, like once a user logs in, we have tailored our UI in a way that if a business users are belong to a specific domain, the suggested prompts are shown up over there. Like, what are the most common questions being asked in that domain? Like here, like what are the insights for the claims? And it comes back with then it breaks down the question into multiple pieces. Like, once, what's the intent of the question, and after that generating a SQL, gathering all the context and generating SQL and submitting that to the Starburst. So here in this screen, we have a summation of the insights for this insights of the claim. And then we have what are the results for that insights, like what's proving for that. Like so this is the final outcome, what we have got, and then the visualizations what we are showing over there. And we're trying to evolve as we speak, adding more visualizations based on the data sets they can play around. And now let's go back to that. Like, when we ask that question, what's helping that to come back to that insights, right? Like how it's being created, like what are the sequels it's generating. So the model can understand that business terminology, saying that, okay, this is the query, and what are the tables, columns, relationships, and few short prompting examples what we have to take, and then submit back to the knowledge base, and get back with the context, and comes back with a SQL query. So if you see, like, it's a pretty extensive SQL, which is like CTEs, analytical functions you can write, very advanced. And if you give it back to the data engineers or analysts, it might take some time actually. So for this to come back for us, like, it's took around maybe a minute to gather that information. And from there, this system can understand now, like, if there is an issue with the SQL, let's say in the first try, the models tend to do that actually every now and then, where we are trying to find the query, and then it might not have that enough information about the question, or it might give you that a function which is not applicable to that engine. So there's a mechanism, there's an agent, which what it does is it goes and retries. There's a mechanism for that. We have a 3 retries for that, and most of the time in the second or first retry, able to fix it, and it shows that okay, this is the first query, original query it generated, and what was a fixed one. And in the bottom, if you see, there is a feedback loop. So constantly we are taking the feedback loop from the users, where what they do is like, if there is an issue with the any output, then what happens is they can write down what was the issue, and then that feedback loop goes back into this knowledge base, and next time when the similar question has been asked, then it can learn from it and get the better results. And adding more context to that, like what tables has been used, and what is the relevancy score for the knowledge base, and what relationships and stuff. And then there is another screenshot which does the few shot prompting, what are the examples which are related to that domain. So one thing which I want to go back and talk about, which I missed out, was, so there is over here we introduced the domain specific drop down too. So they can, what users can do is, they don't have to, we don't want to put it out across enterprise level, rather they can pinpoint what domain they are asking. So there is a drop down over here which is not there over here, but so that way the results will be very accurate within that domain. Okay, so let me jump into the architecture right now. Give me 1 second. Yes, so let me deep dive into the architecture, how it's been built out. So there are, if you see, there are 5 components to this architecture. If you see the left side, like there's query intelligence. So once the user asks an NLP question, so we have an agent which break down the question, like what is the intent of that question? Is it a knowledge question or a data related question? Or it might be the question which is not clear, where model needs more inputs for that. So follow-up question, it might go back with the follow-up questions, or it might be a guardrails, like some prompt attacks or something like that. So we have placed that intent in a way that it can figure out intelligently the categorization of those, and then comes back with either data query or a knowledge. From there, once we figured out the intent, then it goes to the domain in the middle box, which gathers all the enrichment, like domain knowledge or business terminology, so the way the user speak or an engineer speak. And we gather all the information of the business terms, the business terminology, which is nothing but like, we created a metadata as well as like very comprehensive, where what we talk, like how this table is being called, or how this columns has been called, what are the descriptions, what are the relationships, that whole semantic model has been ingested into this knowledge base. We gather all that information, submit to the vector database, and then there we do the hybrid search, where we have the semantic and the lexical filter search to boost the score. And then from there, it submits to an agent which is forming the context for us. So based on the intent, if it's, let's say, if you go by the SQL, we take that SQL context, submit to the third one, which is the actionable insights, where we submit for the chain of thought. Like, so we have this prompt with the context, with all the information about the business, the question related to that business terminologies, tables, descriptions, and everything. And then the model will understand that semantic of it, and then comes back with a SQL. So let's say the first time, as I said, like first time when I submit that SQL, it might go and submit to the Starburst, and then it might error out. There is a mechanism where it can catch those errors and tries to refix it. So we have that looping mechanism where it intelligently find out how to fix that SQL and comes back with the results. We have not seen like most of the 95% of the time we are seeing like the model is fixing at least by the first or second turn. And once we have that results, then we have a summarization of the insights and then the visualization picture. And if you see the bottom of the page, like we have two other components. One is the continuous learning and feedback loop. So we, as I say, like we keep on take the feedback from the users, what because they know much better than what it's on the business side and the technical side, right? So we take those information and then come inject into back to knowledge base. Once we have that into the knowledge base, again, the next time when I ask a similar question by someone from the team, then it can fix it in a better way. And we have a unified knowledge foundation, which is in the middle, which holds the whole data semantic model, which is as all the KPI related information, table relationships, everything related to the model. And this model is also, this architecture also helps to onboard, or somebody is learning to know new domain, they can get the information faster with this, not just the SQL side of it, at the knowledge side of it. Like if a new engineer join and they want to know how the churn rate or how the turnaround time has been calculated within the domain, and all that information, if they ask that question, the it can understand that okay, it's a knowledge question, and it has to drive towards the documentation piece. And let's so with that, like, we gathered some metrics actually on this for past few months, where for the documentation piece we have seen a tremendous help actually. Like it boosts time saving for the engineers, because when somebody asks that question, like how do I find this information and stuff, somebody has to stop their what they're doing, like a data engineer or an analyst or a data product team, and then come back to that information like after like a couple of hours or 3 hours. So there's a time delay, and then it might affect the people, right? So that's the reason like this documentation piece really helps to save time, and as well as the SQL generation piece too. So we at least we saw 50x time saving around this. And with that, like I'll pass it on to Rajesh. He'll go through the what lessons we have learned with this approach, and where we are heading towards the next phase of this technology.
Thanks, Karthik. So just to recap, like a couple of things that I want to highlight. Like one thing is, the first one is the need for this NLP, right? So why do we even need NLP for data democratization? Karthik actually came up with a very nice way to give you chronologically what happened, right? And this is like a constant, I think, endeavor that we have had, where we want to automate this whole thing and get the users who need to have the data to make those decisions at the right time, at the right speed, right, and with the right quality. That's the end goal. So if you assume that we do have an ideal end state where every person in an organization has that exact amount of data at the right time, the right quality to make their decisions, that is what I would call the ideal end state, where the organization is data driven. And for that to happen, you need to put this data in the hands of those people who are actually making those decisions. And they are not obviously the data engineers and the analysts who have in-depth knowledge of how this system is built. So those are the users who are like very, very well versed with business, and they are like well embedded into the business teams, and they are the ones who actually understand how to use this data and make those decisions that will impact the company or the organization, right? So the big barrier there is twofold. One is the lay of the land, like how this whole data is set up in our enterprise. In our case, like Asurion, we have a huge platform which consists of thousands of tables. And how do I find, like, if I just ask somebody, hey, where do I have customer data? Probably I'll come back with 100 tables that have customer as keyword in that. So it is humanly impossible to go and understand how the nuances of how data is laid out and all of that. The second big, I would say, second big barrier is the language or the technology. So in our case, we might be using Starburst Presto, and it has its own syntax, right? And some other company might be using some other version of SQL, or maybe they built a wrapper on top of Python open source SQL engine, and it might be doing the work for them. Or somebody else might be using another version or flavor of SQL. So there are so many nuances to how do you get to the data. And first of all, you need to be SQL savvy. So these are the barriers that prevent people from getting the data that they want. And what natural language does is, that is what everybody is equipped with, right? As long as you can fairly describe what you want, we can get the data to you. That is the biggest, I would say, uh, hump in the road that you need to cross to get to this end state, or the ideal end state, where everybody who is supposed to have the data gets the data. So that is the why part. And the second piece that I want to highlight is the biggest challenge that you will face when you're going from the hello world to something like this is the scale. The scale is going to act not in your favor, because as I said, if I ask like where is my customer data, probably I'll find 100 tables which have customer keyword in that, right? So that is one of the fundamental problems that we try to solve, that is like how do we, and even if you don't have those many tables, even if you only have 10 tables which have customer data, they might have been created for 10 different use cases or 10 different purposes, or maybe 10 different teams have a different definition of customer, right? Team 1 might define customer as a household, and team 2 might define customer as an individual, and team 3 might define customer as an individual mobile phone number or email ID. So you will end up having different variations and versions of this. So it is as good as you hiring a new person onto your team and teaching them how to interpret each one of these. So one of the early decisions that we had to make was, how do you make this more logical organization of this data? So that is where the data domains come in. So if I'm asking the same question from HR domain versus finance domain, it means two different things. So if you cannot explain that to a person, you cannot expect the machine to do the same kind of um, or you cannot expect machine to have the same understanding, right? It cannot magically make it up or understand that, oh, you are coming from an HR perspective or you're coming from finance team perspective. So that is where the domains will help. So you are basically grouping these tables into logical groups so that you can provide them, you can provide accurate answers and relevant answers. All right. So the lessons that we have learned throughout this process. Two big problems that we learned are the metadata sparsity and completeness. That's one big problem. The second one is deterministic query generation. So I'm not surprised by the metadata sparsity and completeness, which is basically saying that we don't have enough metadata, and we don't have, wherever we do have it is incomplete, because metadata, again, as I said, is not a technology problem. It is a discipline, and it is not going to prevent anybody from to provide solutions or deploy projects to production. You don't need to have metadata to deliver your projects, but you do need them to scale your projects or your outcomes. So that is one of the things that is fundamental to making NLP work, because if you cannot describe your data, a machine cannot understand what your data is, right? So that is one of the first problems. The second one is the deterministic query generation, which is when I'm asking a question, especially when I'm saying in this case, business users have to make decisions based on this outcome, you cannot be hypothetical or you cannot be approximate. If I ask a question, how many customers did we serve on 21st of March? It doesn't matter like how many times I ask a question, you need to always come up with the same answer. You either served 300 customers or you did not serve 300. You cannot be 300 on the first time I asked, and you cannot be 305 the second time. And so that is a problem if you're using a large language model, because these are not built for determinism, right? So that is actually a foundational problem. So how do you solve that? So before we go into and I explain like how we are tackling those, the second box you see there is how we describe like the lay of the land in terms of making LLMs work in for NLP analytics. The left side is where all of your data descriptions are, like what is your business terminology, lineage, query patterns, relations, governance, right? Who gets access, KPIs and metrics, whatnot. And then on the right side is taking all of this data, doing a semantic search on this, and providing those chunks of information to a large language model, and it can come up with a query. Then you iterate on the query, execute it, get the results, summarize it, produce to give it to, or share it with your user. So that part, the last part where you're doing a semantic search, and then you're assembling the context and then providing the results to user, that is just 20% of your work. 80% of work is in describing your data. And unfortunately, most of the solutions that we have found are focusing on the 20%. So they're already assuming that your data is well described and 80% of the work has been done. Now you just connect all these dots and then produce a solution. So that is not where the work is. That is the easy part. The difficult part is describing the data. And it takes both humans and machines to get to that 80%. So that is now focusing on how do we solve that 80% problem. So this is where Starburst actually helped us in a couple of ways. One is you need to before I get to how Starburst we are using Starburst, I would like to say how we are trying to solve the 80%. So within that 80%, what we are saying is you need these many 15 different things for your machine to be able to produce the right query. And one option is to I would expect all these 15 things to be in place, which is the chances are remote because it is humanly impossible to manage this at scale because humans need to describe this. And again, as I said, it's a discipline problem. So I don't think that is scalable. The second way is, can we use machines actually to produce this data so that I can use the same metadata to make another machine to write my query? So that is how we are trying. So what we are saying is, can I use AI to fill the 80% gap so that another AI can actually use that metadata and then produce a query? So that is where we are trying to work our way backwards. So what we are saying is, if I know the query patterns and if I know how my users are interacting with our data, can I use that and take the help of AI and derive these data so that I can populate my metadata and probably get to 70% coverage than 0%, and then fill that last 30% using humans. And now that I have my data descriptions, then I can use another AI to work on top of it and say that, okay, now you have described data, now assemble the context and give me the results. So that is one of the approach that we are going with. And here what we are doing is we are taking advantage of Starburst because it's our single pipe through which all of our queries flow, either to users, to applications, to visualization tools and everything. So we have a central place through which we have visibility on how the data is being used. So that's a big advantage. So what we are trying to do with that is we are trying to work our way backwards. As I said, if I know that this is a Power BI dashboard which answers the questions about these three KPIs, then I can actually provide the screenshot of that dashboard, and I know exactly what query is being fired there. Using the query, I can derive what tables, columns, and metrics are being populated. So I can give all of this information to a model, to an LLM, and ask it to produce the data description for it. So it is working a little bit backwards, but that is how we are trying to cover that 70% gap because, as I said, this is the hard work and this is like human work, and it is not scalable. And the second thing where Starburst helps is data products. So if that is the touch point through which our users are consuming the data, and some of our users are also trying to produce the data using data products where they can create materialized views and define views or use business logic to create all of the data, they have the ability to describe the data right there. So we are also trying to capture as much metadata as possible through that interface. So that is also another way we are trying to fill that 80%. I mean, some of that 80%. So that is how we are trying to solve the first problem, which is the metadata sparsity problem. The second problem, deterministic query generation, the determinism comes into place because of semantic search. And semantic search is fundamentally search based on meaning. So if the model thinks that it understood your meaning in one way versus another way, it can pull completely different results. So how do you fix the determinism is you do not want to use semantic search. So you need to be exactly sure that this is what I need. So what we are trying to do is we are trying to flip this whole semantic search on its head and say, I'm not going to use semantic search. I'm going to go with deterministic search. Basically going backwards and saying how a human would formulate a query if I ask a question is exactly what we are trying to do with a model. So if I ask a question, how many users did we serve yesterday during the time frame A and B and in this region, and how many of them are our premium customers, for example. So in that question, I should be able to easily identify what are the metrics I'm looking for, what are the filters I'm looking for, and what business area is this for, so on and so forth. So that is how a human would break down the problem, and they will look for those connections and then build the query. That is exactly how we are trying to go with in this new methodology, which is core component driven methodology. So if a user asks a question, we are trying to break down the question into its fundamental units. Like these are the metrics, these are the dimensions, and these are the filters. And then I'm going to literally do a no longer semantic search, but I'm going to exactly do a keyword match for my KPIs and for my filters and for my dimensions. So either they are there or not there. So I give you an answer which is accurate, or I don't give you an answer at all. So that is something that we have been testing. And out of this whole architecture, the only thing that's changing is in that red box, where instead of using approximate semantic search and queries and query patterns, we're going through KPIs. So this is showing initially great results again. So hopefully what we will do is we will test it at scale, and I'll be back to share more about how that is working or not working with this group. So that's what I'm uh, planning to do next time when we talk. So to wrap this one up, the key takeaways: metadata and quality of data are foundational. You cannot ignore those. NLP is key to democratization, and the heavy lifting is in the describing of your data, not assembling the context and then providing that to the user. And the core component driven methodology is key to deterministic query generation. And the next steps we are working on refining the core component based architecture. So we want to make that as seamless as possible to transition from the previous one to this architecture. We want to test that at scale. So we have great results, as I said initially. Then I'll be more than happy to share the findings when we talk next time.
Awesome. I really can't wait for that. I was saying at the beginning, it's every time I hear this, I'm taking more notes. Like this is a new space for a lot of people. It's really interesting to dive into a real use case, so you can see what Asurion's doing, learn from it. There was a question really quick: is there a GitHub repo which is accessible for text to SQL components? Do you know of any? Do you know if that's true?
We don't Right, we don't have a GitHub repo yet. We can share some of the open source libraries that we're using. The rest of it depends on how we actually plan internally to either put this on a GitHub or not. So we can definitely share the open source components.
Perfect. We'll share that and share that around. Interesting questions that I've had as we're talking, that may be simple, but to start, how did you pick which model to use?
Karthik, you want to take that?
Yeah, so we started with like more than 3 or 4 models. We started with ChatGPT 3.5,
Yeah.
and then now we are using Claude 3.7 actually. So one thing which we saw constantly was Claude was outperforming with the complex queries. Like if you're given a context with complex relationships and the information with a huge prompt context, Claude is outperforming so much. Like so that's where we have gone with Claude due to the accuracy of the sequels. So we have a bunch of evaluations we did against each model, and then we went chose
Cost,
Claude.
performance, the normal things. Yep.
Yeah.
And then
And another thing that we found is these models are like way smarter in terms of writing a query, as long as you provide the context, right? They come up with we try to confuse the model as much as we can by giving complex scenarios describing which would actually take like windowing functions and CTs and all of that. So piece of cake for the model, right? As long as you describe and you have actually well documented data descriptions, that's the complexity of the query is no question. I mean, it's not a barrier for the model. So that's what one thing that we observed. And as Karthik said, like Claude always outperformed GPT.
great. Good to know for the users looking to implement their own. My next question was a little bit about, we talked about data questions versus knowledge questions. So I was wondering if we could dive in a little bit more there and kind of the complexities you needed to up level to those knowledge questions, right? Like what challenges did you have to do when you went to that next step?
Yeah, for the knowledge questions, So we have bunch of documentation piece internally. So one which we are leveraging whatever with the knowledge base we already have it, like the descriptions. It might be an calculation based metrics, how this metric has been calculated and all those things, or some might be different level of documentation which we might need actually. So we have internally Confluence pages, Backstage documentation, Markdown files, bunch of sitting around there. So we index those, and then the intent will find out that, like, okay, based on the question, okay, how do I categorize it? Is it a data query or a knowledge question?
And sometimes the
Right.
user may be looking for not actually the data, but they might be asking the question like, how is this even derived, right? How is this built? And that is one of
Mhm.
the common questions that comes from other engineers or other teams that are consuming this data. And that is a knowledge question. And you wouldn't be able to solve that or answer that question by looking at the query patterns. So we also leverage a lot of documentation. So as part of our pipelines, again, you need to have the discipline to document all of your engineering documentation is key. So if there is documentation in our Git repos or any markdown files in eConfluence, and sometimes Slack channel conversations also help where people have explained something. So as long as you can pull all of that and then push into your semantic search, it's available for the model to pick it up and then answer the question. So that is not the difficult part. The difficult part is, again, as I said, that 80% where you need to have
Mhm.
documentation.
And the one thing to add was this helps also find the gaps also, like what we have and what we don't have. If model doesn't come back with the like the information, then it might the gap will engineers will find out and they'll go and fill it up. So that really
That
helps.
that is another use case I did not think about that could be extremely helpful.
Yep.
Yeah. So another question is building up that unified knowledge foundation that we had at the bottom. So obviously we've talked about all of the data quality that you just mentioned. We talked about specifically filling out those knowledge questions, but I was wondering, so how do you get all of that information into vector search? Do you have pipelines, or what is done there?
Yeah, we have a separate ingestion pipeline for that.
Okay.
So we read all those things, and that's continuously flowing into the knowledge base and the learnings also, like whatever we have, the continuous learning. So at some point, maybe down the line, 1 2 years, we might have the enough metadata captured. We might fine tune our own model and have it place it internally.
Right, right. And so right now, and you're getting, just piecing it all together for me, you're getting that information from the Starburst queries, right? So you're writing something, get that information, put it into the knowledge base.
Yes.
Yes,
Right,
some of the data is queries. Some of the data is
which,
human descriptions, right?
right,
Uh, some of them are documentation pieces, like as I said, like if somebody is updating a data pipeline and they have an elaborate description of how they are pulling this data from these 5 tables and what decisions are they making in joining this or ignoring some data, or all of that is described somewhere. So that also helps in adding context to the model to make, basically you are trying to collect the collective information or knowledge that is existing and provide it to the model, right? Just like you would do that for another person on your team. If you hire a new developer, what would you do is exactly what we have to do. So
right. And I think what we're learning, and I mean what you two have demonstrated today and the rest of your team, is it's all of the pieces of the pie. What internal documentation can you do? What query patterns can we get from different domains? I didn't really put it together about the different domain piece until you showed that. That is so cool because I know we've talked about having different definitions, especially for these larger organizations. How did those challenges come up? How did you work through those challenges? Because I know some have a big dictionary, or did you just decide it was easier? I mean, obviously you decided it was easier to go with one domain definition. How did you work through that?
so at least, I mean, you have to start somewhere. So we started with a couple of domains and started categorizing all of the existing knowledge. So where does it go? For example, if you take like a customer domain, right? Those are the exact things that I defined. Like there are different variations of how do you what makes a customer? Is it a person? Is it an email address? Is it an MDN, which is a mobile phone number, or is it an address? So there are so many variations of that. So you need to basically draw a line and say, okay, for everything related to a customer, these are the things that I'm going to collect, and I'm going to categorize or tag them as customer domain. And everything related to finance, I'm going to separate this and put this into finance domain and tag it as finance domain. So when the user is asking a question, instead of going open-ended and confusing the model, we are saying, okay, which domain do you want? Are you approaching this from your question perspective? Are you asking this question in the finance domain or customer domain? So that way we narrow it down. So instead of searching the context for 3,000 tables, it will narrow it down to probably 30 tables. So
Right.
your
Which is
accuracy,
still crazy.
yes, your accuracy goes up because of that lower, smaller context.
Right, right. But then it's about picking, I mean, I used to have 3 customer tables in the same domain, right? So it still is difficult. That's where you need that supplemental information to get you to pick which one, which is important. So I was watching experience, I've played with some of these models myself, and the quickness. So we're talking a lot about the business users being able, who maybe have some SQL but don't have the full background. The other thing is just basically the developer efficiency, right? Of being able to get a query spun up. I mean, it used to take me a week to write something like you showed and get that tested and fully in. And now it's like, you said a minute. That's
Yeah.
insane. So what kind of outcomes have you seen there on the developer side, or the business side, really?
Yeah, the metrics actually the one which I've shown over there. So yeah, it's saving a lot of time. Like example, I think
Yeah.
around the if a user asks a business user ask a question about okay, I don't have this data mart or some data is missing, right? So the engineer has to stop there and do like 4 hours of time he has to spend on that and then come back on that. That's what one of the example we've seen. So that's a drastic help over here, like 4 hours versus 1 minute.
Yeah,
Yeah.
so we measured some of these in real world, and what we also did is, and there are other nuances that I would love to share next time when we talk, is where do you expect users to come to you, or do you go to where the users
Mhm.
are? Because a lot of these conversations happen in Slack or Teams. So
Yes.
we were also trying to go there and then inject this there, but there is another nuance to this, because in case of Slacks and Teams, if the user who is asking the question has access to probably finance data, and if the bot provided all the data there, everybody else can see. So how do you apply the role based access control so that only the person who's supposed to see and all of that? And again, that is another place where Starburst is helping, because we take advantage of all the pre-built uh, access controls. So when in this, at least in the interface that you are seeing, we are impersonating the user. That means they are only supposed to see, I mean, they're only getting the data what they're supposed to see, right?
Mm.
So they're, even though I'm asking questions about HR data, I don't have access to HR data. So the query, probably even if it writes the query, it comes back with unauthorized, or it comes back with zero results. And
On.
the productivity, yeah.
Go ahead, Raj,
So
sorry.
the productivity part is like 50 times improvement is like 1 minute versus 4 hours. So we tried to do the same work without taking the help of it, and it took half a day to come up with one of those queries. And the best,
Wow.
yeah, talking
That's
to different teams and then understanding nuances versus letting it come up with the query. Yeah.
Wow, that is awesome. And then I the role-based part, separating out the data domains. I was curious about that. You just answered that question of how you do it. And then the last thing I want to touch on is just anything else you had to add on data products. I know you said yours, like, this is a touch point for where the users are consuming the data, but how does that play a role here?
Yeah, two things. One is like we want to enable some of our users who are SQL savvy, and also they know they don't need to wait on engineers to go ahead and then build this whole thing, right? So can we enable our users with last mile ETL? That's how data
Mm.
products is one of the options. And also, while data products, if users are creating last mile ETL and materialized views using data products, then we also want them to be taking advantage of all the features that are available to describe the data, catalog it, and then tag it, whatnot, right? So if that is the place where the data creation is happening, whoever is creating is the most knowledgeable about their stuff. So we are trying to gather as much information as possible to fill that 80% gap again. So that is also another way Starburst data products helps.
The AI to build the AI, when you were talking about that, I was like, that is so awesome. That is really cool.
Yeah.
Really cool stuff. Karthik, Rajesh, I want to thank you both so much for being here. I really appreciate it. And I know all of our listeners and anyone who's going to see this will really appreciate it too. And I just, want to take the time again to thank you. And again, we'll chat next year or maybe before that.
Yep.
Thank you.
Thank
Thank
you
you.
all.